Hello, everyone, and welcome to my talk. I'm delighted to be here with you today, and I want to thank Emily and James for giving me the opportunity to speak to you today. In the next 15 minutes, I will be telling you how we at InnoGames predict user value and how we use it in our marketing efforts. Ties a bit into the talk that Fischer gave earlier. After a quick introduction about InnoGames and myself, I will tell you about the background and the goals that we had during the project, as well as the methods and the technical implementation that we went for. We also tested the model that we built for user prediction, and I will also let you know about the learnings that we did on the way and the next steps. So InnoGames is a gaming company established in 2007. We are headquartered in Hamburg, and we currently have a little over 400 employees from 30+ countries. We make annual revenues of around 190 million euros, and we are a member of the Modern Times Group, which is a Swedish media house. Our gaming portfolio mainly encompasses city-building games, but we also do have strategy games as well as fighting-focused games and resource management games. My name is Jan Krumpholz, and I somehow dressed up as a random emoji from the internet. I'm a senior marketing manager at InnoGames, and I've been with the company for about 4 years now. And I've been in the startups, gaming, and e-commerce industry since 2014. If you want to talk to me later about the topic, feel free to do so, but also talk to me about cheesecake if you want. So to give you a bit of background on where we were coming from on this project, I brought with me the user acquisition process and the tracking process that we currently have. So we do run ads on different advertising networks. Users see our ads and they click on them. They are redirected to the app stores. They install our apps then, and depending on the opt-in choices they make in terms of privacy, we get a certain amount of information from them in our player database. We can return information about how the users behave in the games to our MMPs, the mobile measurement partners, which are the tracking providers and the neutral third party within our relationship to the advertising networks. And from there on, we can ping back information to our advertising partners, for example, installs, purchases, and so on. So why did we at all want to go on with this project? So first of all, the users stay in our games for quite a long time, actually, and they do not spend necessarily money early on. So we are missing currently a lot of information that we could provide to the advertising partners, and that could be used in marketing optimization. Other than that, also back in 2018 and 2019, Google and Meta, they started propagating a more consolidated campaign approach, which meant that you should be sending at least 50 signals per 7 rolling days to them in order for their algorithms to be able to optimize properly. And then last but not least, being able to send high-value early funnel events to our partners might give us a competitive edge, and might also enable us to take part in more auctions more successfully. So when we went on in this project, we took basically 3 categories, or we had 3 categories of goals. There were, of course, technical goals. So we wanted to increase the number of signals that we sent to our partners. We wanted to do so via our MMP in order to be able to use the signals that we send additionally with a lot of different advertising partners. If you go into a project like this means an investment for you, like basically monetary as well as in time-wise. So we wanted to see some return on it. We wanted to be able to spend additional money on advertising, as well as being able to see the same ROAS than we have in our regular advertising campaigns. And finally, we also wanted to learn something on the way. So we had educational goals like knowing which signals to send, when, how, why, and so on. So as said before, users stay in our games for quite a long time. And they do not make payments early on, or at least only few of them do. So what we always have been doing in the past is that at some point in the user's lifetime, we start predicting their LTV until a certain date, and based on this, we determine our return on ad spend. What this project now endeavored to do was to actually predict who will ever become a payer in their lifetime within our apps. So how do we do that? So over the course of the project, we basically identified 6 factor categories that go into our prediction model of whether a user will become a payer at some point or will forever stay a non-payer. First and foremost, there is the payment history. So it's kind of obvious, but if you look at a user and try to predict whether they become a payer, if they have already become a payer, you do not need to predict it anymore. Then we look at device level information. So we look at which devices the user is using, what did the device cost, which OS is running on it, and so on. We also look at information from our game shop. So how do the users behave in the game shop? How many times do they open it? What do they do? Do they initiate a checkout? Do they close it? And so on. We then also look at information related to the game progress, which means like how many resources does a user have in their city? What is the population on the city? And so on. We also look at game event-related information, which means like how many logins does a user have? Or are they a member of an alliance, for example? And finally, we also look at the pay events, because in our games, you basically buy in-game currency for real currency, and then we look at how the users are spending this money in the game. If they are saving it, what do they spend it for, and so on. And based on these factor clusters, we basically make a calculation, and we predict the score somewhere between 0 and 1. And then based on a threshold that we can set in marketing, let's say 0.7, we determine and we put the users into one of 2 buckets, either predicted payer or predicted non-payer at some point in the future. Now, if you make predictions like that, you cannot be right all of the time, because users just might behave differently from what you expect from other users, or you have just missing information. But on average, we found out that for the users that we determined to become payers at some point in the future, the LTV 30 is 32 times higher than for the group that we predict to be non-payers. And at the same time, we increased the amount of signals that we are able to send by 14 to 77 times, depending on the measures that we set. So how does this tie in with our process now? So users still see our ads on advertising networks, they still click on our ads, they still get redirected to the app stores, and they install our apps. And we get some kind of information about them in our player database. Our model then accesses this information in the player database, it's called EASY, Early Success Indicator, and then calculates the score and writes it back into our database. From there, we can take it and forward it to our MMP via a tool that's called MAPI, which is the marketing API. It's a tool that we use for campaign management internally, and that would be worth another talk at some point in the future. And from there on, we can basically ping back the predictions also back to our advertising partners, for example, to Meta, and we can use it there in the custom event optimization campaigns. So after building that, we were also eager to test it, obviously, and we did so in selected countries in Europe on Meta, actually, for our main title, Forge of Empires, on Android. And we used a target group of male users who are interested in gaming, because they are basically our core target group. So what we found out in the test was that we are actually able to send 77 times more signals, and that we are also able to achieve a 2.2 times lower CPI. However, we also found that the ROAS in the test group was 4.5 times lower than the ROAS we had in the control group. And that was because we sent a signal every night for each user for the first 7 days, because we wanted to maximize the number of signals that we sent, because the feedback from Meta and Google was we have too few signals, so we wanted to go for the other extreme. We found out, however, that this extreme approach is also not correct. And what we learned from the project is that you should ideally fire your events somewhere between day 3 and day 7, because this gives your model enough time to access the information in your database, but still is close enough to the install in order for the algorithms of your partners to optimize properly towards it. You also want to have an install to prediction ratio somewhere between 2 and 10%. In our test, we had a ratio of 80%, which was just way too high. But 2 to 10% seems like the optimal approach. We also found out through the runtime of the project that predicting payers is actually quite hard. It also might seem obvious, but predicting non-payers is actually a lot easier. If you build a model and you want to have the highest accuracy, and you have a game where basically 1 to 3% of your users make payments, the model will learn to predict 100% of the users will become non-payers, because then it has an accuracy of 97 to 99%. So perfect. But you really want to predict the payers. So currently our model has an accuracy of around 94% for non-payers and around 75% for payers. And this is basically the optimal trade-off that we found between the two numbers. Then also explanations are multidimensional. I showed you the slide about the factors. So initially you might want to go easy, or you have an idea of a concrete factor that is like the main determinant of your outcome. So for example, in our case, that was playtime. We imagined the more the users play, the more likely they are to pay, but that's not the only factor, and you will have to adapt your model if you want to build one. And then last but not least, control groups aren't really controlled. So in our testing, we found out that actually between the control group and the test group, although we set up a proper A/B test on Facebook, the delivery was quite different for the two groups. And they also saw different creatives, like within the range of creatives, more often. So based on these learnings, we are currently basically adapting our model. And we will need to keep adapting our model. As you know, both Google and Google and Apple, they are changing the advertising system rapidly. But to what we know right now, at least for the self-attributing networks, it will still be possible to use the predictions in the future. We also look forward to expand our testing to worldwide campaigns. And we want to have predictions for all of our games, basically, not only our main title. And last but not least, we will expand predictions also to iOS and desktop campaigns. That's it from my side. Thank you very much for listening. I hope you have a wonderful afternoon, and if you want to get into contact, feel free to hit me up on LinkedIn or visit our corporate page.